excited. So this kind of feels ready when you are.
Okay, so I'll start now. I'm going to be talking about evaluating choropleth maps. What I'm going to be focusing on is the accuracy of looking at the values on choropleth maps as well as the performance time. So this is kind of the overview of what I'll be talking about. I'll give you an introduction to the topic. I'm going to be talking about the hypotheses that we came up with, as well as the tasks we used to approach them. We're not going to look at variables because I think there's too little time. We're going to talk about the experiment and the results. So first of all, can anyone see this polygon and tell me what color it is? Yeah, okay, great. You can still see the polygon, yeah?
Yes.
Still there? Still the same color? Okay. What about now? A bit more difficult to see. It's quite small, but it's still there, it's still visible. I'm going to add a couple more things. Now maybe if you blinked, it's a bit more hard to see, but you can still see it right here. Okay, can you see it now? I got a nice big arrow there to kind of highlight where it is. No? Oh, well, that's kind of strange. So this is Brazil. And, we can use this as a choropleth map, but really, if you try to use this as a choropleth map, it would be very difficult to be able to tell specific values. You can see around this coast here how many areas there are. There are over 10,000 areas on this coast, and you can't really see any values from them. And so we created some hypotheses based on this. So we assumed that the smaller the size of the unit area, the higher the error rate of perceiving the colour. We assume that the smaller the unit area, the more time it would take to perceive the colour. And we also assumed that users would actually prefer to have larger areas rather than smaller areas. Okay. So we have some related work to talk about. We can look at the perception of colour. So with Ritchoff and Calvi, they look at remembering or identifying stuff on a map. So they're given different types of maps, the maps, choropleth maps, cartograms, and they were given a set amount of time to look at them, and then that map's removed and they were told to identify different data on the map. We also have perception of colour here. I got a sample on one paper we looked at, which is from Lee and Seidel. And they have an algorithm to optimize colour on choropleth maps, and you can see the differences on this map here. So this is the original colour map, and then that's the optimized one using the algorithm. So you can see quite a big difference, and you can see the colour saliency is quite important and quite looked at. And we also have the perception of size. So that's by Gramazio et al. And they look at identifying areas within different marks. Sorry. So on this map you can see a purple mark here, so the task was to identify where the purple mark is, and you can see it's quite a lot easier to find the purple mark here rather than that or on any of these. So we're going to look at the different tasks that we identified. So the first one would be to identify the colour of a given unit on a choropleth map. So we can see here, I've highlighted this green area, and so the user on the right says the area is green. We have a second task here, which is to compare two different areas. So you can see the area here is orange, and the area here is blue. And so the user has to identify whether they're the same colour or different colours. And you can see he identifies correctly. The areas aren't different colours. And the third one's a more controversial one. select the preferred minimum unit area on the dynamic choropleth map. So in this instance, we only have two. We have the default map, and we have a generated map using my dynamic choropleth maps algorithm, and you can see the areas are a lot bigger, and then the user would identify. So we have a lot more. We have identified 30 images for that, which we'll talk about later in the results. Okay, so we're going to look at the experiment itself. So I created an application in order to log all this information in. The user would interact with the application on the right here, so they can select which color, and then here you can see the software has identified this area. So this is the area that they would have to identify and log into the results. They can also identify or interact and tell the application that they can't tell what color it is. They can also log and identify how confident they are at the end of each set. And so we did this on a specific computer, so the color was always the same, the size was always the same, and we also, unfortunately not seen in this, but we have asked the users to stay behind a certain threshold in order to make sure that moving in and out or physical zooming wasn't implemented. So we're going to talk about some of the results, but first of all I want to discuss some of the different implications of the experiment. We have the 10 past participants of varied data or varying age, skill ranges. They were offered £10 Amazon vouchers in order to do the test. We took 50 data samples per task 1 and task 2, and 5 data samples for task 3. No participants failed the tests, and then we filtered out some different areas. So items over 20 seconds long were removed as outliers, which we'll discuss a bit more later on. And then we gathered results for 50 pixels or less, as that seemed to be the key area we were looking at. So that means we had 466 data samples for task 1, 490 data samples for task 2, and 25 data samples for task 3. So here are the results for task 1. So this is the main plot that we made. So we can see the pixels on the y-axis and the time taken on the x-axis, and you can see the green is kind of scattered everywhere. As you go down below 50, you can see the error starting to occur with some outliers just above. But you can see blue is just a bit lower than that again, and that's where the user could not tell what the color was. Underneath that we have another graph, or a frequency graph, which shows the total amount of times that the pixels were shown, as well as the error rate below. So you can see the blue and the red here, one pixel is very close together, and that shows a large error rate. And so we did some statistical analysis on this using Pearson's R to check the correlation. So for hypothesis 1, we wanted to check the error based on the size. So we look at this graph here. So we checked this on the 50 pixels, and we found that there was a negative correlation at 0.7 or negative 0.77. So that shows a strong negative correlation between the two. We also did Pearson's R on the time taken, which is on this one, on the top, and that also shows a negative correlation, not as strong, but still one identified. On the right here, we just have another varying graph for the left one here, and it just shows the average error. So you can see above or below 10 pixels, we stay at a consistent 25% error rate, which is quite high. Now we look at task 2. So task 2 is the comparing between the two areas. So we can see the distribution isn't quite as straight actually for the correct. They seem to be below 10 seconds. But we can see that there was a lot more frequency on could not tell, so this kind of shows that people are more likely to risk when they have an idea of, or when they don't have an idea between, when they're not too sure between two areas. And you can see that the error rate isn't quite as high. So there's a large incline here of the error rate, or decline of the error rate, as we get to 10 pixels. So we also use Pearson's R-ness, and corresponding with this, we found that the correlation wasn't quite as deep as task 1, but it is still 0.433, or negative 0.433, which still shows a negative correlation, or a strong negative correlation, whereas the time taken was roughly the same. And you can kind of see here, again, the accuracy percentage. And now we move on to task 3. So task 3 is a strange one. We actually, in the pilot study, we added more range to the left side, assuming that this would be more popular with the users. But the participants actually went the other way, and they seem to favor the larger areas, especially, as you can see, with Japan and Brazil. And so we're just going to look at a few of these comparisons. So this is Japan, this is the default one that was shown, and this is the preferred one on the right. What's interesting is we gleaned from talking to the participants that this area was the most important with these decisions. I don't know how well it shows up on here, but they like to see the consistency with the islands. So these small islands on the right side are fully in one colour. So that's quite an interesting observation. I also have another one with, that's not supposed to happen. Sorry, hold on. Okay, we also have Wales here. So you can see the distribution here. There's a lot of areas within southeast of Wales, between Cardiff, whereas they're not so evident here. And that kind of works with our assumption that areas would be enjoyed much larger. And so for our future work, we wanted to extend the survey with a large data sample. So we did only have 10 participants, but we're looking to increase that in the future. Stricter rules for performance time. We try to avoid using the performance time to affect the accuracy. We thought that if we applied any pressure, that would affect the accuracy negatively. But people were a bit lenient with the performance time, with times coming at over a minute, where people were just, readjusting or, sitting down. And that's why we had to filter them out of the results. We also want to look at an enhanced framework for area size preferences. So as I said, in our pilot study, before our pilot study, we assumed that people would like the lower areas, and so we added more. Whereas in our actual study, people preferred the larger areas, so we need to find a larger sample size for the user to decide through, so they don't just try picking the end results. And also we found boundary design was quite problematic. In the pilot study, we found that people were finding it easier and finding changes in color because small pixel sizes were being completely surrounded by the contour boundary design. And so it made it very easy to assume what color was being shown. And that's it. Any questions?
Any questions for Liam?
That was 1 minute over, by the way.
I respectfully disagree.
I got 13 minutes.
You have 15 minutes.
I thought you said 12 minutes plus 3 for questions.
It's on the program at which it hasn't been released yet.
Right. Well, okay. I was basing that on what you said on Tuesday. So.
I'm hoping to send the program to Rich today and to put on the web.
Right.
But the full papers will have 15 minutes each.
Okay.
Yeah.
Including questions, or?
No, not including questions.
Sure.
Oh wow.
So I'll assume it's 15 minutes.
Possibly that one.
Yours is a short paper, right?
No, it's equal.
You don't have to use, it's no big deal, you don't have to use 15 minutes.
Yeah. It was just...
In your case,
important.
I would recommend adding some information.
Yeah, I cut out all the variables because I thought I'd go over.
Okay.
For example.
Okay.
So.
Did everybody understand Liam's talk? Like,
Why don't you use Pearson?
Pearson's on.
Yeah, Pearson's rank.
Because we were checking the correlation between um, the size and the areas. So when we plot them on the scatter plot, it only made sense to use Pearson's R.
Okay. I'm just checking you understood it because I can never remember. There have been times in my life where I've really understood which ones to use, and after about 3 weeks I forget it.
Pearson is for two continuous variables.
Yeah,
Okay.
so I didn't want to talk about it because I've been looking through some user studies and they never mention what the study actually is or the test. They just say, well, this is the test. Almost like they assume you should know it. So I didn't know if it would be, like, what's the word I'm thinking of? I didn't want to seem as if I was looking down on people by going, well, if you're not sure about what this test is,
Yeah. Okay.
obviously it's Pearson's on. You know? But yeah,
That's what-
no one ever mentions it in
That's really interesting.
papers.
They don't.
Yeah. Which I kind of don't agree with. But
Yeah, I definitely think needs to be mentioned.
I know why nobody has questions. It's because you all took the user study.
Yeah.
Okay, so how about
Dylan has
comments?
a question.
Did you have a diverse
Like I said, varying
Section.
ages,
Varying
varying
ages.
gender. I actually had a
Varying.
misspell. I looked at it and it said data, which is why I got confused. So I need to change that to gender. I don't know why I said data. Gender, age, and
disciplines?
disciplines. Yes.
Varying.
Very different.
You know, if someone asks me this, I'm just gonna lie. So
Is that ethical?
please don't. Please blur that out on the video.
It's very common practice to have, computer science postgrads as user study participants. What I would do is, I would just tell the truth, and if somebody says, that's not good, you just say, future work, to test a full spectrum from age 0 to 100.
I think that was in your future work anyway, wasn't it? It's our biggest study group.
Yeah.
So he's got that covered.
Follow-up study.
But that's
Yeah,
That's a
always
debate.
the excuse, isn't it? Future work.
it's a debate.
Yeah.
But yeah, it's a good default thing to back up. Okay, on slide 1, let's get into the comments then.
Sorry I was late by the way. I thought we were in the kitchen. I wondered where everyone was, and then I checked my phone and both message.
Sure.
I would show an example of a choropleth map on this slide.
Sure.
Just
Yeah.
may as well get it out of the way, because a lot of people won't know that term.
Mm-hmm. Yeah, as you can probably tell, that's a better image that I just found online.
I like the target in the
I was
question
trying to
mark.
find
You can put the choropleth behind the target in the question mark. That would be really good.
yeah, with the other talks, well, with the last talk, like I could just take an image from the paper, but I felt like I couldn't take an image from the paper because they're either statistics or, they were like halfway through explanation, like some of the variables, so I couldn't take those or sample images of the exam.
It doesn't have to be from the paper. You can
Yeah, I know. Well, I was trying to find something to do with the magnifying glass. Something looking at a map or something. I couldn't find any good images of that either. So I just, in fact, I put it on like 5 minutes before today. So just
Slide
because
2.
I couldn't find the image. So page 2.
I think I would add another example onto this slide. It's just so boring.
Yep.
You can
I
just
agree.
throw on another choropleth in that big white space.
I need to add the related work as well, and well, we'll see about variables.
Yes, I would really, really love to see the control variables
Mm.
as somewhere on a slide.
Future work you got as well. So.
Thank you. It's true. So I just need to update this. Yeah, and I can. I don't know what image I put on. Just another choropleth.
Yeah, just another choropleth be fine. Now I think
people like this talk.
Yeah, I thought that was good.
Okay.
That one, go. We can't see anything. Go back. That one.
Exactly.
Okay. Should I change the color?
Is this on the screen now?
It's the.
This is photo.
Oh, I can't see it. This projected as up though.
I mean, the whole point is that at this point it's supposed to be kind of silly to ask someone, and then you get to the real silly stuff. So that's silly. This is also silly.
That's the same.
Well, yeah, but I mean, it's the same one.
It'd be good if you made that dynamic so that you see it zoom out instead of how it's seeing it now.
I'm not going to do that.
It is the same area, isn't it? It's just zoomed out.
Yeah.
But so I like this. I like this part of the talk. It was fun. It was engaging.
Sure.
But at the end, you have to state the question. How large does an area have to be in order to perceive its color? You have to state that question.
That's why I moved straight into the hypothesis, because I was trying to discuss what we were looking at, but I didn't actually state.
No, you need to state that question explicitly at the end of this before you jump into the. And I have this slide for introduce the user study first. What is the question you are trying to answer? You know, you would say, how big does an area have to be in order for it to perceive the color? We don't know the answer. So in order to answer this question, we conducted a user study. That vital thing was missing.
I need to remind myself. How should I remind
You can write it on a slide. I would put the question on a slide that says how, and you can put it on that slide that you can't see the area. You have a slide where the area is too small and it's like yellow on a white background. You can put the question down at the bottom.
Yeah.
There, you can put it at the bottom. How big does the area have to be in order for its color to be perceivable?
Well, but that will ruin like the flow of this entire section.
Anyways, somewhere you just put it at the end.
Yeah, I think I need to add it here before I talk about the hypothesis. Because if I had another slide, then I have to fill that slide. Is the problem?
You don't have to fill it. It could be its own slide. Like boom.
I might just add an animated text that comes in, but not animated, just so when I click it, if I try to rush to the hypothesis, then when I click it, I'll know that I've screwed up. Also, I've forgotten to remove the one from introduction, because I was planning on doing a separate slide as well, but I just switched it to the hypothesis.
Okay, and you want to double check your slide numbers. That's my fault, but I think your slide numbers are not.
Yeah, they're cheating basically. These are all 3 because they're all introduction.
Okay.
So.
Slide 6.
Yeah.
Okay, your slide numbers. There's something wrong with your slide numbers.
These are all
See?
6.
Okay.
Because they're all this fast.
I see. So this one, I wouldn't use the word. I don't think that this task is controversial.
Okay.
The word you're looking for is subjective.
Subjective. That's what I meant.
Yeah, I know.
Yeah.
I guess if you want to get everybody to sit up and like start hazing you with nasty questions, then you can use the word controversial.
I don't mind people hazing me with nasty questions.
But generally, I would choose the word subjective.
Yeah.
And in slide 7, you know, you read my mind. You would discuss the control variables because we spent such a long time trying to refine.
And that was the problem because I didn't want to put too much emphasis on that instead of talking about the results. So, I assumed that we had 12 minutes. So I thought if there's anything we cut out.
You would have a slide for that anyways.
Yeah, I have the extra slide already.
Oh, good. Good.
Not finished, but I have the
Placeholder.
Yeah, I have my placeholder.
Good.
But that's why I talk about in the future work, I talk about the contour line, and then people go, why did you use contour line? And then I go to the...
Okay. Bait and reel.
Yeah.
Good. And slide 11, if the slides are... So I would just explain the axes. Like
I did kind of skip that over.
Yeah. This is kind of a difficult graph to understand, actually.
Mm-hmm.
So I would just...
Did I even mention it was a frequency graph?
I don't think you mentioned the axes at all. Okay. Except you said, you did mention we added more variability along this area, but you didn't say what those axes are. And of course the y-axis is more confusing than the x-axis.
Yeah. Well, I mean, you know what it is, but...
but even I have to look at it for a few seconds to remember, like, what is that? Like. So
it's the frequency of the selected minimum area size per map, which is the color. So on the right, we can see Japan. 3 people selected Japan's highest minimum screen space requirement.
Awesome. Okay. Any other questions or comments?
So I was mainly just wondering about the exercise at the beginning of seeing the color, and then also the tasks. I don't know how professional that stick man is, the stick woman.
I didn't even notice the stick man.
I did the stick man.
Actually,
you didn't notice it.
I didn't even notice the stick man. But it's fine with me.
Custom made. A lot of effort put into it. But I wasn't sure if it stuck out because I wanted to show the user to say quickly, you know, this is what they'll be seeing, and that's their answer. But I thought it might look a bit unprofessional. But if no one minded it, I'm keeping it.
You might want to. You don't need that word dynamic. Actually, it was dynamic, wasn't it, with the slider? Okay.
So I don't even talk. I should probably. I didn't want to talk about like the dynamic choropleth map paper too much.
Yeah.
It's a problem because I'm the main author, and so I don't want to say me or McNabb.
Yeah.
It sounds a bit strange. So I just kind of tried to gloss over that.
Awesome. Thank you, Liam.
There's one more thing before you leave. Can you go to 13? Very quick correction. Okay, the bullet points color is black here, but the others are green. Yeah.
That is green.
Let me just double check. I can't tell on the screen. Yeah, you're right.
Yeah, hey! How on earth did you notice that?
I prepared myself for today.
It's the wrong green. It's the green for my title.
That's really funny.
I think that's partially my fault, actually. The template is not that great.
I assume you want that.
Good spot.
Look on my Google Drive.